Hello everyone, welcome back. So in this lecture, we'll talk about these two another forms of the solution for underdamped system. So this was our second form and this is third form and this is first form. Already we find out the constants in the first form A1 and A2. This is the value of A2 and this is value of A1. And in the last lecture, we discussed how did we arrived on these values. So this was A1 and this is A2. And in our first form, we find out these constants. Now we'll talk about the determination of a and phi. So here we'll find out a and value of phi. So as in last lecture we discussed, in the first form this a and phi can be given by a equals to a1 square plus a2 square and phi is tan inverse a2 over a1, right? So here we'll find out the a. So a is a1 square plus a2 square root of this. As we know that a1 is x naught, right? Already we find out this is x naught square plus a2 is this value. So this is x naught dot plus zeta omega n x naught over 1 minus zeta square multiplied by omega n and square root of this and square of this and square root of this whole term, right? So now we'll simplify this. So if we simplify this, then this becomes 1 minus zeta square omega n square x naught dot square, and this is x naught dot square plus zeta square omega n square x naught square plus 2 zeta x naught dot x naught and omega n divided by 1 minus zeta square omega n square and square root of this, right? So if we simplify this, then this becomes, if we take the x naught square omega n square common from these two terms, so this becomes x naught square omega n square, and from here this is 1 minus zeta square, and from here this is plus zeta square. This is x naught dot square and plus this term. So this is 2 zeta x naught dot x naught and omega n, and this term becomes square root of this, and denominator becomes square root of 1 minus zeta square and omega n square becomes omega n, right? So here this will get cancelled out and we'll find out a equals to x naught square omega n square plus x naught dot square plus 2 zeta x naught dot x naught omega n square root of this and divided by 1 minus zeta square root and omega n. So this is a. And phi, as we know that phi is given as tan inverse a2 over a1. So phi we can find out. So this is phi. Tan inverse a2 is x naught dot plus this is the value of a2, right? So zeta omega n x naught, this is zeta omega n x naught divided by 1 minus zeta square root omega n, and this is a2 divided by a1 is x naught. So this is multiplied by x naught. So this is value of phi, right? Or we can write tan inverse x naught dot zeta omega n x naught omega n square root of 1 minus zeta square. This is how we can find out phi and a. So now second form of this is completely known to us. This was a zeta omega n t cos 1 minus zeta square omega nt minus phi. So we can insert the value of a and phi in this equation, and this is the complete form of the solution is known to us. Now this is our third form, right? A naught e raised to power minus zeta omega nt sine 1 minus zeta square square root of omega nt plus phi. Here a and phi is given by, this was the third form, and a is given as a1 square plus a2 square and square root of this, and phi is tan inverse a1 over a2. So already a and a naught both are same, so we can find out the a naught as in similar way. So this is a naught. Now psi is, so in the third form was a naught e raised to power minus zeta omega nt sine 1 minus zeta square omega nt plus psi. So a naught is equal to a only. So already we find out the a. So a naught we can find out in similar way. And tan psi is, so this psi is tan inverse a1 over a2. So we can find out tan inverse a1 is x naught and a2 is x naught dot plus, this was zeta omega n x naught and divided by 1 minus zeta square omega n, right? So in the if we simplify this, then psi is equal to tan inverse x naught omega n 1 minus zeta square over x naught dot plus zeta omega n x naught. So this is how we can find out our third form of the solution. So now here 1 minus zeta square omega n is omega d, right? So this is the frequency of damped vibration. Here in this all form of solution we can replace 1 minus zeta square multiplied by omega n as omega d. So this is the frequency of damped vibration. Frequency of damped vibration. This is omega d, and which is equal to 1 minus zeta square multiplied by omega n. So from here we conclude omega d is always less than omega n. From this formula we can give this statement: omega d is always less than omega n. So this was about the underdamped system where zeta is less than 1. So in the next lecture we'll talk about the critically damped system, and as we know that in the critical system zeta equals to 1, so we'll develop the solution for that particular situation. Thank you.